Hello everyone, and this is Delivery Infrastructure Processes and Tools event. We recorded it talk by talk and share with you on YouTube. We recorded it in our Prague office, but with this online or maybe like recorded event, we have it available for all of you. So with all that conditions we have now in the world, it's maybe a good and effective way to share thoughts. So please enjoy and share your comments and post your questions. My name is Mikhail Levin. I'm a Senior Director of Engineering in Wrike. And first of all, I'd like to say that being a manager, it's always nice to have something side work to do, and tooling, especially tooling for testing, for improving performance of your processes, is something that you definitely want to try to do because it's fun. It can actually provide quite a great results, and this is what I'm doing during my career, trying to not only managing things and people, but also trying to improve tools and speed up all the processes. First of all, I'd like to give you some context regarding our company. Wrike is a collaborative work management solution, as we name it. This is a software web application that let people to collaborate on different things and manage different projects. For example, they can create tasks and do whatever you can imagine with the tasks. They can users have a lot of possibilities to manage, to plan the work, to plan the big projects. We have a quite extensive Gantt chart for that. There are other representations of work. There is a calendar, there is a table view. We let people to collaborate on images, on videos, and of course we have different types of plannings, of reports, of resource management, and at the same time we have mobile applications that help users to reach all the functionality on the iOS or Android devices. From the process perspective, we have 30 plus Scrum teams, well maybe even 35 now. We have only one product. In general, we do this product with all the teams. Well, we have to say that there is also iOS and Android and different kind of integrations with other platforms. But generally, yes, we do all the one project, and the fun part is that we actually use it too, and we manage all our work in this product. We have Scrum teams, and QAs are the part of the team, just to mention that we have all the resources inside the Scrum teams. We have daily deploys, which is heavily affect how we work. We choose this way, and we find it very effective and flexible, but it's require full-blown test automation, because this is the only way we can handle all the regression we have. And of course, we have a great DevOps team that help us to tune all the processes, help us with tooling, and it's a pleasure to collaborate with guys. So this is sort of process-wise things. And with this recording, we have 3 videos. We planned to have my talk briefly regarding how Selenium moves from Selenium Grid to Kubernetes. Then we have a Vitaly Markov talk, who describes in separate video our solution Callisto for Kubernetes Selenium infrastructure. We plan to have also a bit separate topic by Kirill Maximov from JetBrains. He was going to talk about SimCity and how it actually can solve many test automation tasks and improve test automation processes right out of the box. It's interesting that we usually think about CI tools as just robots that run all our jobs, but it's interesting to find out that such tools also contains many different features that can mute tests, manage all the instability tests and so on. Unfortunately, because of all this coronavirus things, he didn't manage to participate in what we have now, which is also heavily, unfortunately, affected by this. But again, we'll see how this format will maybe replace and be more effective than previous offline cases. And finally, we have a video from Ivan Krutov, who represents AirCube, quite famous by their tools in Selenium infrastructure, and his talk is about Chrome Developer Tools protocol and how you can also run it in Kubernetes. This protocol is quite effective thing, and it's interesting to check how we can add it to our Selenium experience to make our test even more effective. Okay, let's move to my part, which is Selenium Road to Kubernetes. And first of all, I'd like to talk about general things, how tests actually run and what we have to think about it. First of all, this running of Selenium tests is quite complex thing. You have many agents involved in this process, and first of them is actual runtime, where you actually run your tests. This is CI agent or something like that, and you can see about it also as a bottleneck, potential bottleneck. If you run tests in parallel, if you have slow or weak machine, then this might be one of the sources of problem. While we're trying to run tests as fast as possible, we tune all the processes, still we can hit this bottleneck. Another part of the story is the Selenium infrastructure, which is a big part of our event, and Selenium infrastructure itself contain many parts, and there might be different type of bottlenecks inside it. But anyway, this is obviously something we try to tune to run tests in more parallel way and get more speed, and still we can have some bottlenecks there, well, a lot of them, and this is one of the places we try to fix. And of course we have to think about staging performance. You run all your bunch of all your tests against this staging where your software is running, and it's quite often happen that you hit these limitations of your staging. You try to run tests not like in 10 threads, but in 100 threads, and it doesn't provide you better results. You don't get that speed up with that increasing of threads, and that's oftenly because of staging performance. So you have to always have eye on this part because it's really important. In between of that agents, you obviously have a network, which is also easily could be a bottleneck. So it's important to think about it too. Okay, speaking about Selenium infrastructure, I will try to touch several main areas that sort of describe how this infrastructure evolves, what are the old approach, standard approach I would say, and what is the modern approach and what it stays on, what is the main part of this approach. Selenium WebDriver is a web testing protocol and framework that allows us to communicate with the browser and perform different scenarios, communicate with different part of interfaces, and replace manual end-to-end scenarios with test automation. Fortunately, we have this protocol and frameworks as a standard since recently. It's W3C standard, and this is a standard for the companies that develop browsers. So we can hope at least that every new browser that will appear on the market will somehow support this protocol, and if we are lucky, we can run all our tests against that new browser right out of the box. And an additional thing I want to mention, it's really important for understanding of the further talk, is that this protocol is session-based. What does it mean? It means that you have your test, you have a WebDriver and a browser somewhere in the network, and you have communication between those two. And when you communicate, when you send new commands to the browser, you always have this session ID in hands. You represent client goes always with this user with session ID to tell the browser that this is me who actually send you commands. So session ID is always in a loop. We always have to have it in hands. And it's really important for further understanding. So there is a standard approach which is developed by the community, by the authors of Selenium Grid, Selenium and WebDriver, and this is Selenium Grid. How does it work? There are, well, I would say there is one piece of code, one binary, then you can run in different ways. You can run it as a Selenium hub, and you can run it as a Selenium node. The idea here is that each Selenium node represents some browsers that can run, and each Selenium node has a property with the Selenium hub in it, Selenium hub IP address. And when each Selenium node is started, you have all the Selenium nodes registered in Selenium hub. They sort of register themselves. And this is how Selenium hub become the important part of the story, because Selenium hub knows everything about Selenium nodes, about their state, about the timeouts, how many browsers we can run there, whether browsers are busy or free. So for that part, Selenium hub control everything. From another part, more or less the same type of story. We have a test that actually expects somewhere in a network, it's looking for endpoint. Test just want to find WebDriver to communicate with. And Selenium hub represents that endpoint. It sort of hide all the infrastructure from the test and acts like it is a WebDriver and a browser. So tests go into Selenium hub start the session and provide the session back to test. And then it proxy all the requests. The issue here is that it actually stores it in memory, and all this mapping between session IDs and nodes are saved in the memory of the Selenium hub. Selenium hub become a very busy and very important person in our process. This thing is well, you know, it's have quite nice job security. You know, it's just we cannot survive without it, because we have to route all our requests to proper browsers with that mapping of session IDs and nodes. And unfortunately, that leads to different kind of drawbacks. For Selenium hub, for Selenium Grid, we have many of them, and first of all, we have limitations in number of sessions we can run. These limitations comes from the first of all type of application you have. If your application responds really fast and your tests are running really fast, and one test replaces another test with their request to Selenium hub, then you can kill your Selenium hub with 60 sessions. It just becomes overwhelmed of that constant new requests and die, unfortunately. And if you have more slow application, if it loads itself for some time until it starts working, then you can stretch it to 200 or 300 sessions. And the bad part here also that you cannot run these Selenium hubs in parallel. You cannot make several of them running on different machines. So you have a strong limit of the most powerful server you have. Another issue here is the warm-up costs. When you run this infrastructure somewhere in the cloud, you have to pay for time until this infrastructure is actually up and running. You have to run your Selenium nodes, you have to wait until they are registered in Selenium hub, and so on. So this is a bad thing. the same problem appears when we have any type of issues with Selenium nodes. If they broke, we have to somehow restart it, and we have to register them again to the Selenium Hub. It actually might take minutes, and all of that things leads to instability and resource consumption. And you can just imagine what happens if you have several of your nodes going down while all your tests keep trying to get the new sessions. You can even have different types of retries in your tests. So you load and load your Selenium Hub with new requests, while Hub cannot provide new browsers and new sessions because of no available nodes. And this is again where Selenium Hub is dying, unfortunately, and you cannot scale it anyhow. Yeah, by the way, the painful updates is also part of the story, because this is software that you have to update as a Selenium Hub, as a Selenium node, and on the testing side. And with all that machinery you put around this infrastructure to keep it alive, this is what you have to always test with new versions. And sometimes it's quite painful. We actually had quite major outages with this infrastructure before because of these updates of new versions. At the same time, I want to say that we actually survived for quite some time with this infrastructure. We gradually moved from hardware to virtual machines with Docker containers, and finally to the Kubernetes. So it's possible to run this infrastructure in Kubernetes in containers. We actually start to run separate new Selenium Grid for each test runs, but still there are a lot of complications, as I described before, and this is why we was looking for alternative solution. Well, how to approach that? Imagine this is a simple picture, almost the same as the previous one. You have your test, you have something in between, and you have your drivers and the browsers. We want to proxy our request somehow from tests to browsers, and if we able to make this proxy as thin as possible, if we can make it Nginx or something like that, then we definitely know that we can handle thousands of requests simultaneously. For that, we definitely have to get rid of that big role of this application in between. We have to get rid of this storage and don't save anything there. And this also leads, if we can manage that, we can also have several of these endpoints, because in this case we don't have to address any sort of database in between. And let's see how it might work. So we have the test, and somewhere in the network we have a Chrome driver with a browser. We want to write some application in between that would proxify somehow our requests. And this is what I'm named Session ID Magic. It is a very simple idea that help us to solve this task. And you know, there is a session ID, as I said. The session ID is important. We use it all the time, and we have to improve it somehow to solve our problem. And the simple idea is so that we can extend the session ID. Fortunately, it's allowed by the protocol. We can add additional hash that will represent IP address of the machine with a Chrome driver, with any type of browser and driver. With this extension, we have the session ID that always goes from client back to the browsers, and so we have this information stored on the client side. So client always come to us with this information, and we can easily proxy all the requests to proper machine, to the proper browser. This is Session ID Magic is really important. This was, well, maybe not invented, but reinvented for some time ago, and this solution is built in different types of known applications, known solutions. This is a grid router, Selenoid and Go grid router. Well, I was fortunate to be part of some of them, at the beginning, and where we firstly implement this solution. Grid router is good for virtual machines. Selenoid works for Dockers, so it only can live inside one machine, and Go Grid router is sort of extension for Selenoid that can help you to stretch it a bit, but none of them are native for Kubernetes, and it's not effective to use them. So AirCube, as the new company that actually drives all these solutions, they made Moon as a Kubernetes native closed source solution that actually works really fine and solve these tasks of running tests in Kubernetes. And we decided to keep it even more simpler with our Callisto solution, which is also Kubernetes native and open sourced. So this is what we did, and the main idea here is again this session ID and simplification. And to keep it simple, there are several maybe final thoughts how to make Selenium in Kubernetes. First of all, it's a good idea to start all this infrastructure every time on request. When you work this way, you can start it with different types of parameters that's necessary for your particular job. For example, you can start this infrastructure every time with different types of browsers. You don't have to set it up somewhere in a cloud. You can run it with predefined parameters every time with new parameters. Another important idea, as I said, is to use this concept of proxying requests. This is the fastest way to deliver information, to proxy something, and we can use this session ID magic to solve this routing problem. Important to mention that there are two types of requests that you cannot proxy with this session ID, because at this stage you don't have it actually. Or it's important to separate this request because you actually create new resource here. You create or you close some resources in your infrastructure, and this is where we actually need additional software that will handle that two requests. And it will create ports for Kubernetes case and delete ports. So it will communicate with with Kubernetes API, and it's sort of more old-fashioned way, but this type of requests are quite seldom if we get all the requests we have. So it's only first and last request, so it doesn't affect your performance. It's also nice to mention that we have these great Selenoid images made by AirCube. These containers, these pods are developed and tested by guys from AirCube, and they are stable, they are modern, so we have a pleasure using them. And just to mention, we always have to think about cleaning up after our work. It's a good idea to be sure that we actually close all our resources. We tried different approaches for that, but anyway, just keep it in mind. You want to have everything closed when you don't need that resources, because it's obviously money. So that's it from my side. Thank you very much, and see you one day on site in our Prague office or on any other online or offline meetups. Thank you.